All right, we've gone over this several times. Everybody got it right, of course. To make our classes, we like to make our data private, our methods public, otherwise they can't be called by the main method, by the driver class. We like to, oh gosh, why did my brain just freeze? Add getters and setters.
Yeah.
And if you broke those up into 2 rules, that's fine, but then you wind up with 6 rules. Add a parameterized constructor if it makes the class easier to use. And 5, add a toString method. Somebody just put add a string. So I wish they were here so I could point that out. Alrighty. We've defined a few class. It's a collection of something with something that acts upon it. Here's the answer that I got that's not quite right. Objects with methods that act upon it. Now, objects are a form of data, but they're not the only form of data because that doesn't cover primitive data types. In this language, primitive data types like ints and whatever aren't objects, they're just primitive data types. In the C# language, absolutely everything is an object. But anyways, we don't want objects and methods, we want data and methods. Static keywords define class variables. And just see if you can burn that into your head. Think of some really classy looking guy with a top hat and he's driving and there's sparks flying off him. Static. Okay. So what do you do? What is that for? We'll go back and look at that in a minute. Which statement is true? A class is an instance of an object. Does that sound good? No, an object is an instance of a class. So, the book calls the client class the driver class. The main method, does it go in the driver class or in the driven class? It goes in the driver class. The driver class is the one that uses the other class. So our main method has been using the other classes. You don't typically want to stick your main method down inside a data class, what they call the driven class. So we would want the main method to go in the driver class. Local variables are defined in methods or as part of a class. No, if they're declared as part of a class outside of methods, they're called instance variables. So we want local variables as being defined in the methods. That's just like int x, you know, and stuff like that when you're defining your for loop variables or your sums or whatever. Instance variables are defined in methods? No, instance variables are part of a class. A UML diagram provides a brief outline of the class? Yep, that answer is definitely true. Please answer. I swear, guys, I had an exam, not just a quiz, where I said, hint, the answer to this one is false. And like more than half of the class chose true. And I don't know if they chose true because they said, yeah, the answer really is false. So true. I don't know. It was an online class, so I couldn't get an immediate response as to why so many people chose true on that one. UML diagrams. Attributes go in the middle block. Class name goes in the top block. And the methods go in the bottom block. A hyphen means it's private. A plus sign means it's public. A getter is an accessor. It gets data, retrieves data. A setter is a mutator. It changes data. Lots of people said that Booleans do other things than what the correct answer is. Boolean variables in this language default to false. Ints default to 0. Strings and all other reference types default to null. Any questions over that? We'll go back and hit static variables again in just a minute. How do I get out of my preview? All right. All right. which is following is true about constructors. Well, we know they're all true, but we're going to read through them anyways. A constructor is a method, yes, that has the same name as the class itself. It has no return type because it's returning that object. A constructor is automatically called when the object is instantiated, also known as created, by the new keyword. It can be used to assign values to instance variables. A class can have more than one constructor, that's true. If you do not add a constructor to your class, Java gives you one. That's true. It's called the default constructor, and it doesn't accept any parameters. That's why we can get away with doing stuff like this. Circle C1 is equal to new circle. We didn't add a constructor. Java gave us one. We don't see it, but it's there, and it doesn't accept any parameters. Then if we really wanted our circle class to be able to accept a parameter there, we'd have to add a parameterized constructor. We'd have to come over here and say public circle, and we'd have to say what it accepted, like that. And then we could do something with that. Once we do that, once we create a parameterized constructor, so-called because it accepts a parameter, once we do that, then Java stops providing the default constructor, and everywhere in our code that we relied upon creating them like this will be broken. So we either have to change all those calls to actually pass in a data as an argument to that parameter, or you can go back and add your own default constructor, and then that'll fix that code so that and the default constructor just looks like that. It doesn't accept a parameter, it doesn't need to do anything. So that statement is definitely true. If you do not add a constructor, Java gives you one. It accepts no parameters. You can define a constructor with parameters that accept arguments. Yep, and then you use those arguments to assign values. And a hint, these are all true. Some people didn't click this one. I'm going to get ahead and give you the point. We generally define constructors to be public. That's true because otherwise the driver class, the main method or whatever, would not be able to use it, would not be able to create the object. What would the constructor look like? Now it looks like I'm missing some parentheses, and I didn't mean to miss the parentheses. I need to edit this question. What would the constructor look like that would accept two arguments that would set the width and the height? So some of these are wrong because they don't accept the correct arguments. Public static void. This one doesn't accept any parameters, so it's not a good answer. This is totally wrong. This is a main method. It's just like, you know, that's completely wrong. Fortunately, nobody chose it. Here we have a constructor being created as void. That's wrong. It has a constructor has no return type defined at all, not even a word void. Also, it's defined as static, and constructors are not static. They're just declared public. So this is looking pretty good. A private constructor would be dumb, so we wouldn't use that one. Also, it's got static and void. This one's looking real good too, except for the word private. That makes this one correct. You define your constructors as public, and if you want them to have a parameter list, you give them. And you don't put static, and you don't put a return type, not even the word void in there. You can use the this keyword to access instance members. That is true. The companion question, which I didn't ask, is you can use the this keyword to access static members or class members, and the answer is false. Oh, well, what do you know? I did ask it. Okay, but I gave you the answer. Note, this is false, and the previous answer is true. Okay. Note that there's no constructor specified, so all it has is a default constructor. So we know how to do this. Circle C1 is equal to new circle. Say you have this class. It's got a constructor, and it doesn't have a default constructor, so this syntax would no longer work. So somebody put this, circle C1 is equal to new circle C1.set radius 10. Technically that would be correct, except we don't have a default constructor anymore, so that line would fail. So our only choice is to use the constructor that is given, which is a parameterized constructor right there. So circle C1 is equal to new circle that accepts a value there. Okay, write a method that will calculate the area of the circle and return it. I'll show you an incorrect answer. Well, let's go down this. Should be called getArea, sure. Should be public, yeah. Should be double, okay. It should accept no parameters. There we go. And the formula to use is this. Now here is a wrong answer, and I have sympathy for you doing it, but this dot area is equal to math.pi times math.pow, this dot radius to the power of 2, return this dot area. That makes sense, but it's not correct. Everywhere we've been adding our getters, we did that. We did return this dot area. But in this case, this class doesn't have an area member to return. So the this keyword is completely wrong. The this keyword only allows us to access variables that are actually defined as being part of the class, so that's not correct. We would need to define that, though. We could do double area is equal to that. That would make it a correct answer. Does that make sense, y'all? When you pass a reference to a method, you enable that method to modify the referenced object. That's true. We're going to dig into that just a little bit more today. You can have more than one method in the class with the same name, as long as the parameter lists are different. That's true. It's called overloading. And you love the Python language. Absolutely. Java. You love Python too, if you know it. All right. You love the Java language. Okay. So I'm going to create a little sample application that uses another class. And I'm going to do the wrong thing, which is to put the other class in the class with the driver. I'm going to put it in the driver class file. And you should never put more than one class in the same file. The only reason I do this is so that we can have both things on the screen at the same time. So if I was going to do this for my own sake, I would then cut this class out and put it into its own file later. But anyways, we're going to create a circle class. We're going to give it a data value. I'm going to mistakenly declare this data value as a class variable rather than an instance variable. And then we may as well have a getArea method. Public static, nope, not static, public double getArea that returns math.pi times math.pow radius to the power of 2. I could not declare this class as being public because you can only have one public class per file. That means that no other project, no other file in this same project could use the circle. Only this one would be able to. That's another good reason to not put more than one class in the same file. But here we go. This is what's known. I'm going to put in some other completely silly variable, a string called color, like we were going to set the color of the circle or something like that. A class variable is one that's defined as static. Our guy with his top hat and the sparks flying off of it. The fact that it's a class variable means that you access it via the class name rather than the instance name. So to get a hold of this radius, I don't do this. I don't do circle C1 is equal to new circle and then say C1 dot radius is equal to 10. I can't do that. I could if radius was an instance method. and it's letting me, but it's giving me a warning. It's saying that you shouldn't access it that way. It's a class variable, which means that you should access it with the name of the class. And what does that mean? It means you don't even have to have an instance of it before you set that. You could set the radius equal to 10. We don't even have a circle. So the math class is defined like that. You don't have to create a math object before you start using math.pow. It'd be really annoying if before we could use math.pow we had to do this. Mathy is equal to new math, like that. And then we could only, start using POW. We don't have to do that because POW and pi and all those other things are defined as static. So they are class members, they're not instance members. We don't have to have an instance of the math class in order to get them going. So what this is saying is that every circle shares the same radius. And even if you don't have any circles, you still share that same radius. That data is stored outside of the class itself, or outside of the instances. Previously we've been using the class to create multiple instances so that we could have one circle with a radius of 10 and another circle with a radius of 20 and another with a radius of 30. If we tried to do that, then when we set that third one equal to 30, the first one and the second one would all be sharing that data value as well. I don't know how to conceptualize it more than that. Just remember that if it's got the word static, that means it's shared between all objects of the same class. And indeed, you don't even have to have an object, an instance, to get a hold of it. It doesn't make sense to have a circle class where they're all sharing the same radius. So that's just dumb. So we would get rid of that, and then that would give this an error, and we would have to set the radius the old-fashioned way. We'd have to make a circle, and then set this dot radius equal to 10. Or not. Not this dot radius, C1 dot radius. There we go. So that works fine. Radius is now an instance variable, as is color. So we could say that this is going to be a red circle with a radius of 10. Whatever. If we were going to make this a well-functioning class, a well-implemented class, we would make these private, and we would make getters and setters for them. There's a real quick, cheaty way of doing that, which is to highlight those two lines, go to Refactor, Encapsulate, and offers to add getters and setters. It makes them private, and it adds some getters and setters. It fluffs out the class considerably because it starts adding some comments, So now our class looks a lot bigger than it did, but it has all the getters and the setters. Typically when I'm writing classes up here, I try to get the getters and the setters to fit all on one line. I'll show you that again, Parisa. Like if we had another variable called width, line width, then if we wanted to encapsulate it, if we wanted to add getters and setters, we would highlight the line. What I did is I just highlighted the line. I chose Refactor. Then I went down to Encapsulate Fields.
Did you get an error the first time you did it?
Yeah.
What did it do?
The first, I highlighted it, did exactly that. Threw an error, did nothing. All I did was right click, do it again, and then it did it.
Huh.
It tried to tell me that it couldn't refactor the Java application 15.
Huh.
So I don't know if it was some sort of holding on to it.
But the second time you did it, it worked?
Yeah.
Okay. Okay, I'm going to undo that last change. This is how I like to do my getters and setters when I'm showing the code on the screen, just to minimize the amount of screen real estate it takes. Now that's a far better class. It doesn't have a constructor. we want to add a parameterized constructor for it, what would the syntax be? I mean, this was the exact same thing as on the quiz, but what would it be? What's the first word in our definition?
I spaced out. Public.
Public, yep. And then do we add a return type or use the word static? Say no.
No.
Alrighty. Then we use a name. What is the name of a constructor?
Oh,
Same name as the class. And then inside here we would give it some parameters. In this case, we only have one that really matters because circle and line width are silly. And in here we would set the radius. This dot radius equals to the radius that's passed in. The last thing we would like to add is a toString method. And a toString method is a good idea so that you can print the contents of the class. If I went down here and printed out my circle right now, I'm going to get rid of this C1.setColorRed. Matter of fact, I'm going to get rid of this C1.setRadius because I'm using a constructor now to set that. But if I did this system.out.println C1, it's going to print garbage. It's not going to print anything useful. It's not garbage. It's just nothing useful. Here's what it prints. It prints the name of the object, the package that it's in, and some random hex number, which is probably the address in memory where that is stored. We'd much rather have it print something useful, like when you print a double, you know, it converts it to a nice number and displays it. So that's what toString is for. It converts this object into a string. So public string toString, and it doesn't accept any arguments because all we're doing is telling it about ourselves. And I'm going to use string.format. String.format follows the same syntax as printf. So I'm going to make a string s. S is equal to string.format. I'm going to give the name of a class. And then inside parentheses, I'm going to put radius is equal to %, I guess, .2f. And then pass in this .radius after that. And then I want to return that string. If we wanted to, we could make it print out more stuff. We could make it print out the name of the color and the line width and all the other data members. So as many data members as you have, you probably want to add to the toString method if they're important for debug purposes. And if they're not, then why are they there? But anyways, so now when I do print C1, it doesn't print that address. It actually prints something good. It says circle with a radius of 10. I hope that makes sense. I hope that explains why you would want toString, so that you can print the object and have it return useful information. Whether that's just for your own help when you're trying to debug it, or whether you actually want to be able to turn that object into something that the user needs to see. Like if you had a date class, no matter how the date was stored behind the scenes, you want to be able to print that date, and it ought to be nicely formatted, month, day, year, or, you know, day, month, year if you're European. So you could even make the date class know which way it was supposed to do it with some kind of instance variable in it that said which order you like those fields to be, and then toString could obey that variable in order to construct the string for display. Okay, we covered toString. We covered static. Was there anything else in that last? Overloading. Y'all have a good idea of what overloading does? Let's add another constructor that not only sets the radius, but it also sets the color and the line width. So above this toString method, we're going to add another constructor. This is our first constructor. Let's add a default constructor that doesn't set anything. Now let's add one that accepts two pieces of data, both the radius and then the color. No semicolons. So this dot radius is equal to radius, that's passed in. This dot color is equal to the color, that's passed in. We probably need to modify toString to tack the color on as well. So I'm going to add something to toString. S plus equals string.format color equals %s, comma, this dot color. So that's what I just added, and then this one right here. That's new as well. So now it's beginning to look crazy. Not really, but we have 3 different methods with the same name. That looks kind of like lunacy. Fortunately, that works. The reason it works is because each one has a different number of parameters. It has a different parameter list. This one doesn't accept any parameters at all. This one accepts 1 parameter. This one accepts 2 parameters. So the compiler can figure out which one we mean. Is it okay if I scroll, or are we still typing? Feel free to say slow down. Okay. Down here where I created 1 circle and I set the radius, I'm going to create another one. And I'm just going to use the default constructor that does nothing. And then I'm going to do 1 more. That calls the new one. It sets both the radius and the color. Then we're going to print out all 3 of them. C1, C2, and C3. So when I ran it, it said circle, radius of 10, color null. That makes sense because nothing ever set the color. And we didn't give a default value for it. We could have said color is equal to empty string or something in there, but we didn't. Here's the next one. This one doesn't even have a radius because the second object was created with the default constructor, so it doesn't have any data in it at all. The third one, we call this constructor that passes in both a radius and a color. And so the compiler hooks them up in its mind. Oh, you're calling this function? Well, I'm just going to figure out which one best fits it. I can't do that one because this one wants 2 pieces of data. I can't do that one because it doesn't accept any parameters at all. I'll do this one. Here we call another one with no parameters. That tells it to zero in on calling that one. And here we call it with 2 parameters, and so it knows that that one's not going to work because there's only 1 parameter. It knows that one's not going to work because there's no parameters. Ah, here we go, and that's the one that it ties it to. That's the one that's invoked. And that's called overloading. We have 3 methods that have the same name. Overloaded methods. Seems to me like they could have chosen a better word because overloaded sounds bad. And really overloading is a cool thing. Sometimes once people get the idea of it, they start going nuts and think, oh, well, I'm going to make a version of circle that accepts an int as well as a double. And then I'm going to accept a version of circle that accepts them in the opposite order. First the color and then the, you can go nuts. And if it doesn't make it easier to use, ints are automatically converted to doubles anyway, so you don't need to make extra versions that accept ints as well as doubles. You can, but there's no point to it. And there is no point to making another version of it that accepts the color before the radius, because that's just giving the programmer too many choices. He won't know why you had 2 different options and how they were going to behave differently. Okay. I have seriously gotten lost on where we are. In Unit 3, we have covered I apologize for that, but I'm also teaching 2 Python courses that are at different points, and I'm teaching the C++ course, which has got very similar material but in a different order. And so I do things like assume that I've taught y'all arrays, and I really haven't. So correct me if I'm wrong, but we've never officially really stepped through the arrays PowerPoint. Okay. We will now. What is it, chapter 8?
Yeah, so you have that string.
Chapter
and
10.
And those curly braces. No problem. Yeah, because we made the constructor and then he said, oh, by the way, here's a string.
You may have seen some warnings on the side here. Seems like you have 2, and I only see 1 over here. But anyways, it says add override annotation. I can do that, and it just puts a little teeny tiny funny comment at override. That doesn't do a darn thing to make your program better. What it is saying is that somewhere else there already was an object that had a toString method.
Oh.
And it did. It's just that it didn't print out anything useful. All it did is print out the name of the class and that address. But we're replacing that one with this one. And so you say, well, where did that come from? Why did it have a toString method at all? That's because every object inherits attributes from a class called object. So if we came down here and we typed object ob1 is equal to ob1 Kenobi is equal to new object like that, and then we type ob1 dot. It doesn't really have a lot of things, but it sure does have a toString. I'm going to print that out just because I wonder what ob1 looks like. Y'all really don't have to add this part to your code. Java.lang.object. That's true enough. That's the name of the class, followed by one of our weird hex numbers. Okay. So that's what the override notation means. That it's replacing a method that was already defined in a class higher up from itself. So arrays. An array, it says, is a class. No, that's not what it says. A class stores a group of data, and then it stores the methods that operate on that data. An array is like a limited class. I don't really agree with this definition, but we're going to roll with it. Like a class, an array also stores a group of related data. But the array does not store methods. And another difference between an array and a class is that all an array's data must all be of the same type. Okay, that's a silly definition. What an array is it's a list of elements, all of the same type. A list of ints, a list of strings, a list of circles, a list of whatever. You can make arrays out of primitive data types. You can make them out of classes like strings or our circle class. Here's a picture of an array that holds a list of speed dial phone numbers. So the array was called phone list, and then the user stored 5 elements into it. If we wanted to do that, we could. Let's go out to our code, and down here at the bottom of main, we're going to make an array. Here's how you declare an array. You use the data type, but then you follow it with the square brackets. The square brackets mean, oh, I'm really making an array. I'm not just making a single string. Speed dial, which I guess has two D's, is equal to new string, and we have to specify how many elements are in the array. This array has room for 5 numbers. So speed dial, the first, you know what, I'm changing that to SD because, or SPD, I don't want to type the whole word in each time. SPD, the first element, which we're calling 0, is equal to whatever that was over here. I'm not going to look. 405, 372, 0987, whatever. Speed dial 1, and you don't have to put spaces, I just put that to make it easier for y'all to read. Is equal to 1-800 fun Java. There we go. Speed dial 2 is equal to whatever, 911. We like having 911. Speed dial 3 is equal to whatever, I don't know. We were just bored and didn't enter the whole phone number there. How many phone numbers have we entered so far?
4.
Right. And we started counting at 0, so what's going to be the highest index value that we can create?
Also 4.
Also 4, right, because we can't go up to 5 because we're doing 0 based. So let's add one more phone number. Speed dial 4 is equal to 1987 Legoland. Here we go, whatever. That's real close to what their customer support number actually used to be. Why do I know that? Never mind. Okay, so we created an array. We said we want room for 5 objects, and then we filled them all in. A slightly better way of doing that, rather than hard coding those numbers, might have been to do this. Don't necessarily copy this, but I could have done this. I could have said, I need an index counter. I'm going to set it equal to 0. And then each time I add a number to my array, I'm going to increase that index number. Like that. Why would I prefer that? Because by the time you're done, the index counter tells you how many items you really have in the array. What if the array had 10, it was allocated to be a length of 10,000, but so far our program has only put in 5 values? That's what's known as a partially filled array. And by keeping track of how many we've added, we know how far we should go in processing it. That's why if I'm doing it as a sequence like that in a program, I would usually do that rather than hard code the numbers. Why did I hard code the numbers? Just to remind ourselves that if something is 5 long, we can go 0, 1, 2, 3, 4.
So you have to define the length of your array when you create it?
When you allocate it, yes.
So if you're not sure, you go on the long side and use something.
You either go on the large side and keep a counter, or you use a data structure that does grow and shrink,
Okay.
like an array list or a vector, some kind of abstract data type. Just for grins, since you asked, I'm going to show this. This is that. It's not going to be part of any homework in this version of the class. This is next semester stuff. But I want to make an array list of strings, and the syntax is going to look very alien. And I'm going to call it SPD2, because I'm not feeling creative, is equal to new array list. Putting spaces in just to make it readable. Come on. There. It's flagging that as an error because just like the scanner, it doesn't have an import for it. But if you click on it and you say add import, those errors go away. I made an error. I said strings rather than string. I have to delete that S. Now I'm ready to add some phone numbers to it. Speed2 dot add 19, whatever. Whatever. Okay. This is a data structure that works in much the same way as an array, but it has some key differences. One is that it grows or shrinks as you add data to it, so there's no maximum size. We declare this array to be 5 elements, meaning that if we wanted to add a 6th item to it, lol, what are we going to do? What you got to do is create a larger array, copy all your old data to it, and then set your pointer back to it if you want to increase the size of an array. And if you do that too often, all the copying of the data and the stuff like that, takes a lot of time. If you have an array that needs to grow past a certain size, if you don't know how many elements are going to be and you can't reasonably estimate, a comfortably large size, then you much would prefer to use an array list. This array list thing can hold not only strings, but it could hold integers. We could declare an array list of integers, an array list of doubles. But a quirk is that I can't do int like that. Instead, I have to do the wrapper class like this. I'm going to call that IA is equal to new array list like that. And then I could add some integers to it. ia.add 5, 6, 7, and so on. Whatever. So we have an array list here of strings. It's got 3 strings in it. We have an array list here of integers. It's got 4 ints in it. So like you were saying, rather than pick a large size, 10,000, because I have no idea, how many phone numbers are going to be in my contact list, you would use something like this.
You
Okay.
can use the wrapper classes for all of them. Or basically
Did you
all-
say you could, or
Yes, if
you have to if you're using an array list?
Right.
It relies on this thing here being a class and not a primitive data type. In other languages, everything is a class. In C#, doesn't matter because even an int is a class. So you could put int there for however you declare the same kind of thing. I don't remember about C++. I should. Okay, so we have all this great data in our array. Let's print it out. Int I is equal to 0. I is going to be our index counter. I've already used the word index, so I'm just going to call this an I. While I is less than the length of the array, spd.length. Now when we use the length of a string, we put parentheses after it, like that. But we don't for an array. And the reason why is .length is not a function, it's not a method in an array, it's just a property of it. It's a constant. Once you declare your array, the length of it's never going to change. So it's not a function, you don't need to put parentheses after length, and if you try to, you'll get an error. Alright, let's print that item out. System.out.println number %d equals %s /n. I should have made this a printf because I'm using those placeholders. I followed by the array element at position I, at index value I. Then I need to increase I. Now when I run that, here's what it prints out. Let me move that over a little. It says number 0 is, number 1 is, number 2 is. It's printing out our array. I didn't have to put the word num there. I could have put speed dial or SPD. I could have put, SPD, and then some braces around that %d. Then it would look, a lot more legit. But now we printed out the array. Did we need to go to all the trouble of making it a printf and look special? Not really. We could have just done this. We could have just done system.out.println the array at position I. I did that so it would look nice and pretty. This just prints out the numbers like that. What do we know about while loops? That pretty much anything you write in a while loop can also be rewritten in a for loop. So I want y'all to do the same thing, but with a counter called J rather than I. And I'm going to leave the rest of it to you. I'm going to go ahead and do it as well. J is less than what? spd.length J++. And then inside here I need a print. System.out.println the speed array at element J, at index value J. And so Parisa, these are just like our Python lists were. They're just more complex to declare. Python makes a lot of things easier. Notice that when you have a for loop like this, well, copy that code, come down here and paste it. So you have two things that do the exact same thing. But then it pops a little warning over here. Click on that and say convert to for-loop. And you think to yourself, well, it already is a for loop. Just run with it. Go ahead and do it anyways. What it does is it changes it to what is colloquially known, and I think the book started calling it in this version as well, a for each loop. This means for each string in the SPD array, print out that string. You didn't have to call it SPD1, it just could have been for each S in the SPD array, or you could have said for each, you could have given it a nice descriptive name, which is friendly to your coworkers. There you go, like that for every phone number. That's called a for each loop. It certainly is a tidier way of writing a print than to have to keep track of your indexes and stuff like that. So I tend to run for this. The cool thing about this is that it also works with array lists. I could come down here and print out this array list the same way. And I don't know whether y'all added that or me saying that you didn't need it. So for every string in the SPD2 array, print out that string. And it would print out that second list now. So when we're talking about these, I'm going to call this style with the index counter just a for loop, and I'm going to call this one a for each loop. The for each loop syntax was borrowed from C#, but when C# did it, they actually used the word each there.
What did you do to get it to convert up the
To do it automatically,
Yep.
there's a little warning over here in the column in the line number. See where 74 ought to be on mine?
Yeah, mine's not giving that.
But he doesn't want you to be lazy.
Certainly not because that's a print out
No,
instead.
no. You click off of it and you're back on it. That's crazy. I can't explain why. Anyways, you see how easy it is to write it. You could write one. That's bizarre. I apologize for that. Okay, so you see what an array is. An array is a contiguous series of elements. This declares the array. This part right here, string, whatever, SPD declares it. This allocates the array. The new keyword allocates it. Just like with objects, we could do that with our objects. We could create a new circle, you know, like this. Don't type this, but C4, and then we could do C4 is equal to new circle. You could split the creation of it and the allocation of it. You can do that with arrays. And if you want to, later on you could recreate the array. Say you're really tired of this speed dial list. You can come down here and do this. SPD is equal to new string and say, well, this one's now going to have room for 10. Well, that's bad news because now we've lost all this data. This array here that's 5 elements long is occupying a certain memory space, and we just said, no, I'm not going to point to that memory space anymore. I'm going to point to this new one. This is an orphaned array. It's orphaned data. There's no references to it anymore. The garbage collector will eventually come in. So it's not like this is going to make a new array and then it's going to have all that data in it. It's just everything that was previously stored in that array is wiped out because nothing is pointing to it anymore. So this is allocate, this is declare, this is allocate. When we were dealing in objects, we were calling it instantiation. This is how you declare a circle, and this is how you instantiate it. Why the difference in terminology? Well, because an array, despite that slide on the PowerPoint's babbling, is not an object. It's not a reference. I mean, it's not a class. So we don't say we're creating an instance of an array. We say that we're allocating an array. When you declare an array, there's an alternate syntax. String colors. I still need my little square braces, but then I can say what I want to be stored in that array. Red, green, blue. That creates an array. It allocates all the memory for you. You don't have to use the new keyword. The compiler counts how many elements are in it. There's 3 elements, so it creates an element in array of list of link 3. So it's a different way to do it. If you know in advance what your data is going to be, that's by far the best way to do it.
I figured out why I wouldn't do that. It was because it was a printf, and the printf was referencing a variable that was the J that was in the header of the other 4. Get rid of it, and then the printf wouldn't know what to put there.
Exactly. Okay, that makes sense. That makes sense. All right, let's stop here, guys.